Okay, for activity 2, this is what one group got. Let me, activity 2. Okay, so we said that F1 was 10 newtons at 0 degrees, and F2 was given to be 3 newtons at 180 degrees. Now, I hope you actually measured it. I went around and looked at all your whiteboards, and you all got 7 newtons at 180 degrees. Was it actually 7? Yes. Yeah. I mean, it was really, really close. This is true. Now, a lot of you probably thought, oh, it's 7 newtons. Why do I even need to do this? But here's what I want you to see. The universe makes sense. Okay? There's a pattern here. It's very obvious and very simple. But it makes sense. And it's very profound. So, 10 newtons at 0 degrees. Well, that's 10 newtons cosine 0, 10 newtons sine 0. You get 10 newtons, 0 newtons. One thing I like the way you did this, group 3. I like the way you showed the sine and cosine. You don't really need to do that. Most of you didn't do that, and you don't really need to. But I like the fact that you did. 3 newtons at 180 is 3 times cosine of 180 is -1. That's -3 newtons. 3 sine 180 is, sine 180 is 0. And same thing for here. So when you add them up, you get 0. So that string that you're pulling on with 3 different forces is not moving. The string is in equilibrium. And when you add up all the forces that are acting on that string, you get 0. Okay? So, if you have, here's, one of the forces like this, and then you, on a loop, and then you had another force like this, and then you had another string, had a force like this. This was 7 newtons, make it a little bigger. This was 3 newtons, and this was 10 newtons. Now, the universe works in such a way that if I put 8 newtons right here, what am I going to get right here? I'm going to get 2 newtons. It's got to add up to that. Because when I add all 3 force vectors together, what am I going to get? If it's in equilibrium, I got to get 0. This is a big deal. Now we're going to move on to activity 3, which is the hardest one.